Let's take a look at this problem. We want to solve the equation on the interval from 0 to 2 pi. And we got sine theta minus cosine theta is equal to square root of 2. Well, we don't like the fact that these are different trig functions. So I'm going to take one of them over to the other side. I might as well take the cosine. That way it'll become positive. So I got sine theta is equal to the square root of 2 plus cosine theta. Now, one of the things we can do is we can raise both sides to the second power. You can square both sides. So we got sine theta to the second power is equal to the square root of 2 plus cosine theta to the second power. Now, sine to the second power is sine squared. And over here, we're going to rewrite this as square root of 2 plus cosine theta times square root of 2 plus cosine theta. And then we're going to multiply it together, FOIL it. You can't just square the square root of 2 and the cosine because the plus in here messes it up. So we got sine squared is equal to square root of 2 times square root of 2 is 2. Square root of 2 times cosine is square root of 2 cosine. Cosine times square root of 2 is square root of 2 cosine. And cosine times cosine gives us cosine squared. Now our goal would be to get everything in terms of the same trig function. Now remember our Pythagorean identities. We got our sine squared plus cosine squared is equal to 1. Now if I want to get rid of that sine squared, I can take this cosine squared over to the right side. And we get sine squared is equal to 1 minus cosine squared. So we can replace the sine squared over here with 1 minus cosine squared. And then back to here, square root of 2 times square root of 2 gives us 2 square root of 2 cosine theta plus cosine squared. Now I need to get 0 on one side and see if it can factor. So I'll take those both to the right side. And I'll rearrange this. So I'll put the squared part first. So I've got cosine squared. And this negative cosine, when I take it out, negative cosine squared, when I take it over, becomes a positive cosine squared. Plus 2 square root of 2 cosine. Plus 2, and then I take that 1 over and it becomes a negative 1. Well, cosine squared plus cosine squared is 2 cosine squared plus 2 square root of 2 cosine theta, and 2 minus 1 is 1. Now this factors, and it factors as square root of 2 cosine theta plus 1 times square root of 2 cosine theta plus 1. When I was factoring it, I had to think, well, what would give me the 2 square root of 2 here if I multiplied it back through? And that's why I figured I had to have the square root of 2's here before the cosine. There'd be no way I could put square root of 2 here at the end and get it to give me 1. Okay, well that looks like the same thing. So we're going to have square root of 2 cosine theta plus 1 to the second power. Okay, now we're ready to set that equal to 0. So we've got square root of 2 cosine theta plus 1 is equal to 0. Take the 1 over, so we've got square root of 2 cosine theta is equal to negative 1. Divide both sides by square root of 2, and we get cosine is equal to negative 1 over square root of 2. If I multiply the top and bottom by the square root of 2, that's going to give us a negative square root of 2 over 2. Now here we have 3 pi over 4, and here we have 5 pi over 4. This point is negative square root of 2 over 2, square root of 2 over 2. And this point is negative square root of 2 over 2 and negative square root of 2 over 2. Now we're looking where cosine is equal to a negative square root of 2 over 2. Cosine is our x part of our point. So it looks like both of these would be our answer. So we got theta is equal to 3 pi over 4 and 5 pi over 4. But we do need to plug those back in and see if they check. So we think 3 pi over 4 and 5 pi over 4. The reason why I've plugged those back in is because we squared both sides. Whenever you raise both sides to a power, you'll get the correct answers, but sometimes you get false answers. Now if I plug in the 3 pi over 4, cosine would equal negative square root of 2 over 2, or sine, what am I doing? Okay, I plugged 3 pi over 4 in here, sine would be square root of 2 over 2, minus, and then if I plug that in, that would give me a negative square root of 2 over 2 at 3 pi over 4. Now this gives us a negative becomes positive, so we've got 2 square root of 2 over 2, and the 2's would cancel, and you get square root of 2. So that one checks. Now 5 pi over 4. Sine of 5 pi over 4 is negative square root of 2 over 2, minus, and then cosine of 5 pi over 4 is a negative square root of 2 over 2. Negative becomes positive, and negative square root of 2 over 2 plus square root of 2 over 2 gives us 0. So that one does not check, and our only answer is this 3 pi over 4.